Yes. This class we are going to continue the preparation of aryl halides. We already studied the first preparation of aryl halides by doing halogenation of benzene. The second one is Sandmeyer's reaction. It is also one of the naming reaction which is used to prepare the aryl halides by using primary aromatic amine. What is that? Primary aromatic amine, simply we call it as aniline. This is a primary aromatic amine. By using this primary aromatic amine, now we can able to prepare the aryl halides. That reaction is called Sandmeyer's reaction, very important reaction for your examination. So when this primary aromatic amine is treated with nitrous acid, this nitrous acid is obtained from the combination of sodium nitrite and one of the mineral acid, that is HCl, right? At the temperature range of 273 to 278 Kelvin, like very normal temperature, low temperature, which gives the respective product, that is diazonium salts. Gives the diazonium chloride. This is the diazo. This is an azo compound. Diazonium salt or diazonium chloride. We call it as benzene diazonium chloride. This step in this reaction called as diazotization. What is that? Diazotization. Right. In the first step, the freshly prepared benzene diazonium chloride. By using this benzene diazonium chloride, now we are going to prepare chlorobenzene and bromobenzene. Right. The benzene diazonium chloride is again treated with, if you want to prepare the chlorobenzene, you have to treat this benzene diazonium chloride with cuprous chloride, right? Then you will get chlorobenzene and the nitrogen gas. If you want to prepare bromobenzene with the help of this diazonium chloride, you have to treat this benzene diazonium chloride with cuprous bromide. Cuprous bromide means cuprous chloride. This cuprous bromide is treated with benzene diazonium chloride. Definitely it gives bromobenzene plus nitrogen gas. So this is the Sandmeyer's reaction, and this is the preparation of chlorobenzene and bromobenzene with the help of this benzene diazonium chloride. This benzene diazonium chloride is initially prepared by primary aromatic amine, which is treated with nitrous acid, which is obtained from the mixture of sodium nitrite and HCl. So this is the Sandmeyer's reaction, right? Yes. Let us move on to the next concept, that is chemical reactions of aryl halides or haloarenes. In this chapter, aryl halides are involved in three major reactions, types of reactions, such as first one is nucleophilic substitution reaction. The second one is electrophilic substitution reaction. Third one, reaction with metals. Right. These are the main chemical reactions in which the halogen containing organic compounds involved. Obviously, in this nucleophilic substitution reaction, we'll study how the aryl halides will undergo this type of reaction. In this concept, we'll study aryl halides, how will enter into this electrophilic substitution reaction, and finally how these aryl halides are reacting with metal and gives which type of product. We'll see later. Let's start with the first one, that is nucleophilic substitution reaction. Here, In this concept, one of the important concepts here, you have to listen carefully. Aryl halides are less reactive than alkyl halides towards these nucleophilic substitution reaction. I repeat once again. Aryl halides are less reactive than alkyl halides towards nucleophilic substitution reaction. Give reason. They may ask a question for 2 marks in your examination. Very important. Why aryl halides are less reactive than alkyl halides towards nucleophilic substitution reaction? What are the reasons? There are 2 reasons. First one is the difference in hybridization of carbon in CH bond of both alkyl and aryl halides, right? But after this, I'll tell you the second reason. But the first reason is the difference in hybridization of carbon in CH bond of aryl and alkyl halides. So let's see what is that concept. Now I am taking both alkyl halide and one aryl halide. Right. This is alkyl halide and aryl halide. Out of these 2 compounds, aryl halides are less reactive than this alkyl halide towards nucleophilic substitution reaction. Why? The reason is difference in hybridization of carbon in CH bond. Right. This is the CH bond in alkyl halide and this is the CH bond in aryl halide. Right. The carbon in CH bond of alkyl halide is sp3 hybridized. Right. We have already studied. In this case, in aryl halide, the hybridization of carbon in CH bond of aryl halide is sp2 hybridized, right? The sp2 hybridized carbon, definitely sp2 hybridized means it has more S character, more percentage of S character. That is almost 33.33% of S character, right? In sp3 hybridized carbon, definitely the percentage of S character is less when compared to sp2, that is 25% of S character will be there. When compared to these 2 carbon, sp2 carbon has more S character when compared to this sp3 hybridized carbon, right? When S character is more, definitely the carbon has high electronegativity, right? When S character is more, obviously electronegativity of the carbon atom will be increases. Then what will happen? The electronegativity of this carbon when compared to this carbon is more. That's why the pair of electron present in the CH bond is tightly held by this carbon due to its more percentage of S character. Due to its more electronegativity character, the carbon can hold the pair of electron of this CH bond tightly towards itself. So that's why the cleavage of this bond is very difficult, right? The cleavage of the CH bond in aryl halides is difficult when compared to this one. So that's why these aryl halides will not undergo nucleophilic substitution reaction when compared to this one. So that's why aryl halides are less reactive than alkyl halides towards nucleophilic substitution reaction. This is the first reason. I hope you understood. Simple reason. There is sp2 hybridized carbon. So that's why I told you difference in hybridization of carbon. There is sp2, there is sp3 in alkyl halide, there is aryl halide. This carbon has more S character. More S character means more electronegativity. That means the carbon can hold the pair of electrons of the CH bond very tightly, and that's why the cleavage of this bond is very difficult. That's why the reactivity towards nucleophilic substitution reaction is less in aryl halides when compared to this one. This is the first reason. That's right. I hope you understood the first reason for this condition. There is difference in electronegativity of carbon in CX bond of both alkyl halide and aryl halide. And this is the second reason why aryl halides are less reactive than alkyl halides towards nucleophilic substitution reaction. For that concept, this is the second reason, that is resonance effect. You have studied in the first PUC concept. What is resonance effect? First of all, it is an effect in which produces the polarity in a molecule by the interaction between lone pair of electron and pi electrons of the pi bond, or in between the two pi bonds of adjacent atoms. Right. In this, according to resonance effect, we can able to give the reason for this condition. I consider one chlorobenzene, right? These are one of the halobenzene. The halogen atom present in the halobenzene, it contains lone pair of electron, right? The lone pair of electron, it has three lone pairs around the chlorine atom in chlorobenzene. The three lone pair of electrons around the chlorine atom involved in the resonance effect. Let's see the reactions. So once the molecule involves in a resonance effect, that will give more than one or more than two, more than three resonance structures. The number of resonance structures increases, that will say that the stability of that molecule. Right. Here the resonance effect involved this molecule. Obviously the lone pair of electron around this, out of these three, the one lone pair of electron of chlorine involved in a resonance, means changes its position and comes to this position due to the formation of bond. At the same time, this pair of electron of pi bond will move to this position and gives one of the resonance structure, that is will be like this, right? This is Cl has only two lone pair, and this chlorine will get positive charge due to the loss of pair of electron, and the bond will form due to the pair of electron will move to this position, right? When this pair of electron will move to this position, this carbon will get a negative charge, and this is the one of the resonance structure. This pair of electron again move to this position and form a bond, and this pair of electron again will move to this position and gives another resonance structure, right? Cl plus. When this pair of electron move to this position, that will form bond. This pair of electron will move to this position. This carbon has a negative charge, right? This is the another structure, and again this pair of electron will move to this position, and this pair of electron will move to this position, and again it will give another resonance structure, right? That will be like this. This pair of electron will move to this position, means there is a formation of bond between these two adjacent carbon atoms, and this pair of electron present in the bond will move to this position and gives a negative charge on the carbon. Obviously this is Cl, right? And again that pair of electron will move to this position due to the formation of bond between these two carbon, and after this the pair of electron will move to the original position, and finally it gives there is a bond formed here, and finally gives the molecule as it is same in the first molecule, right? These are the resonance structure 1, this is a structure 2, this is a structure 3, and this is a structure 4, and this is 5, right? These are all the resonance structures of chlorobenzene, right? In this resonance structure, you can observe here, we have seen here the structure 2, 3 and 4, the bond between carbon and chlorine shows partial double bond character, right? So due to the presence of partial double bond character, the bond length of that double bond character is 169 picometer. This 169 picometer, which is lesser than the Cl bond present in another alkyl halide. If I consider another alkyl halide, right, this is the methyl chloride, right. In these resonance structures, there is a partial double bond character between the C and Cl due to the resonance effect, and which having a bond length to 169 picometer. That is very less when compared to CCl bond in methyl chloride, that is 177 picometer bond length, right? It is very less when compared to this one. Obviously, the bond length is inversely proportional to bond strength. When bond length is more, bond strength is less. When bond length is less, bond strength is more. Obviously, this double bond character has more strength when compared to this single bond. So that's why the cleavage of this bond is very difficult, right? The cleavage of CCl bond in aryl halides is difficult due to the presence of double bond character due to the resonance effect. But here CCl has 177 picometer, which is more than this bond. This is easily cleavage when compared to this one. So that's why this molecule, what we call aryl halides, are less reactive than this molecule towards nucleophilic substitution reaction. That is the resonance effect, right? In this molecule, chlorobenzene or any halobenzene involved in the resonance effect, the lone pair of electrons present around the halogen will involve in a resonance effect and gives number of structures, resonance structures. In the structures, the bond between CCl is partial double bond character, which is strong in nature. It is not easily cleavage. It is very difficult. So that's why these are less reactive than common alkyl halide towards nucleophilic substitution reaction. Right. This is the second reason. Right. Let's see one example for nucleophilic substitution reaction. When aryl halides are treated with aqueous NaOH, what will happen? Let's see. When chlorobenzene is treated with aqueous sodium hydroxide at the range of temperature 623 Kelvin, pressure of 300 atmospheric pressure. Definitely a very simple reaction here. This halogen means chlorine present in the chlorobenzene can be replaced by the OH hydroxy group. So simply we call it as the replacement of hydroxy group, right? And which gives the respective product, that is phenol. So this is one of the simple method. It is used to prepare the phenol, and it is also a commercial method for the preparation of phenol. And this is the reaction of aryl halides with sodium hydroxide. Replacement of hydroxy group will take place. This is a chemical property of aryl halide.